All right, everybody, let's get this show started. Good afternoon, everybody. Welcome to the North Carolina Museum of Natural Sciences. Happy Saturday. Today is Dino Dig Live Day. This is very exciting because every week this summer, the paleontologists, the dinosaur experts who work here at the Museum of Natural Sciences are headed out into the field where they are this very minute looking for dinosaur fossils. Well, fossils of all kinds, including dinosaurs, that they can study, research, that they can dig up, bring back here to the museum and help us learn more about the ancient world. And what's very exciting is while they're gone all summer, somehow they're able to get just enough cell signal to call into the museum and give us all an update on how they're doing, what they're finding, what's interesting, what's not interesting, what life is like as a paleontologist, what it's like to dig up dinosaurs out of the desert in a place like Utah, any and all of those things, and very cool, answer your questions about the work that they do here at the museum and in the places where they go look for fossils. Joining me today, well, you can all see, up here on the big screen inside the Daily Planet Theater is Dr. Jennifer Anay. Dr. Anay is the assistant manager for the SCCU Dino Lab within the Dueling Dinosaurs experience here in downtown Raleigh. And Dr. Jen joins me now. Hi, Jen.
Hey, everyone, back in Raleigh.
How are you doing today? How are things in Utah?
Well, Chris, much drier. The other week it was very, very wet. Made us sad, couldn't dig up stuff as much, but it's been much drier. And as you can tell from my hair that's kind of doing a windsock right now, it's very windy. So I've got quite the little jury rig going on here, keeping all of my equipment from blowing down the side of the hill as I'm talking to y'all.
Oh, that sounds, that's a very exciting thing. The things you don't think about when you're doing field work. It's not just digging up dinosaurs, is it? It's dealing with the weather. So, Jen, tell us, give us an idea of exactly where you are in the world right now, and give us an update. What have you been up to the last few days?
Okay, well, I am kind of in the middle of nowhere, central Utah. And by middle of nowhere, I mean we have about an hour's drive to go get some groceries. Fortunately, dinosaurs like to be in the middle of nowhere. We're currently have one quarry open because we've been so productive in the last week that we actually finished up one of our quarries that had a big old duckbill dinosaur called Eolambia. Finished that one up, and we're now digging in just our one quarry that has a whole bunch of different fossils. So a little Eolambia, which is really neat, but then just a jumble of fossils. So picture if someone took a Lego set and just sprayed it across the carpet. That's kind of our problem. I don't know if you'd call it a problem because we like lots of fossils, but fossil on top of fossil on top of fossil on top of fossil. So just trying to get down and get all those fossils out of the ground.
Oh, wow, amazing. Well, let's start at the beginning then. Tell me a little bit about this dinosaur you said that you were able to finish up. I think you said it was called an Eolambia. What type of dinosaur is that, and what exactly did you find when you found it?
So our one quarry is a very large Eolambia, so older adults. And Eolambia is in that kind of duckbill dinosaur group. So the guys that have the flat faces, that kind of look like a duckbill. You get a lot of them out here. It's a very common dinosaur out here, but we're excited because usually you don't find a very large or a very small individual. And this summer we have both. So the quarry that we finished up was a very large individual. We're talking ribs like that long that we have to hand carry out. So kudos to the people who had to backpack that all the way back to camp. But yeah, that was a quarry we had found in a previous year, and we wanted to go back, see if we could find some more. We know there was a little bit of bone poking out. Wanted to gather that, make sure we get all the fossils, so really look around the area. And once we were like, yes, we've got all the fossils in the area, we then have to completely close it down. We want it to look like we were never there. partially because it looks bad, but another reason is even though we're here interested in the ancient ecosystem, we have to also remember that there's a modern ecosystem here. There's lots of plants and animals that are calling this home now, and we want to make sure that we're doing right by those critters that are alive today and making sure we're not leaving our big old footprints everywhere.
Very cool. And then I guess you said that this quarry that you just finished with this duck-billed dinosaur is very different from one that you're working on right now, because the one right now is just piles of fossils. So how did you know, for example, that you had an Eolambia skeleton, and then over here that you've got, how do you even know what you have in this new quarry?
Good question. So, just like if you were trying to distinguish between animal skeletons today, you would look at the bones, and each animal has different features on those bones, shapes, where muscles attach, how joints go together, how their limb proportions are for how they're going to be moving. So we're looking at the bones that we're pulling out of the ground, and we're saying, okay, let's look at these features. First off, what group of animals do they belong to? Okay, this looks like a duck-billed dinosaur. Then, okay, let's look at these certain features. Which dinosaur does it look like the most? And we can distinguish that it's an Eolambia. Now, saying that sometimes when we bring fossils out of the ground, we're not 100% sure, because when we pull them out of the ground, we leave a lot of rock on there. Believe it or not, rock is really good for protecting fossils on their journey from the field to the museum. So we want to leave as much rock on there as possible. Taking all of that extra rock to 100% say, yes, we know exactly what that is. That's the jobs of the preparators, like myself, back at the museum. So some of these fossils, we can 100% say that is an Eolambia. Yeah, it's got the very distinct, like, here's that thing. Yep, that checks that box. That checks that box. It's an Eolambia. Other ones, because there's so much rock, maybe it's a little eroded away because, time does that to fossils. We can say, okay, this looks like Eolambia, but we'll have to wait till we get back to the lab and really clean it all up to say 100% for sure.
Very cool. How did you find these fossils?
When we're first looking for fossils, of course, we've got to pick an area to look. So we look at geologic maps, and what they're going to tell us is the type and age of rock that's at the surface. So that's why we decided to come to Utah. We're kind of interested in terrestrial ecosystems, so land ecosystems, during a time in the Cretaceous when it was very, very hot. So Utah's got those rocks exposed, and then you start going for a walk. It's called prospecting, so your eyeballs are going to be your best tools, really, and it's actually my favorite part. It's kind of like beachcombing, but you're, in the middle of the Badlands and you're looking for fossils. You do find shells, but you start looking around, looking for bits of fossil that have eroded, come out of the rock. And when you find those pieces, you then try to find where they came from. So if there's a hill, they probably rolled down the hill. And once you think you found where they came from, you start digging around, and your hope is that there's more of it. Sometimes there's not. Sometimes all you get little chunkosauruses. You're like, oh, okay, that eroded away before we got to it. Other times you will find lots of bones, and you're like, okay, this might be a quarry. We might have to spend a couple field seasons, not just one, coming back here. So it's really a mixture of looking, finding, and then a little bit of luck.
at least a little bit of luck involved in the scientific endeavor of paleontology.
Absolutely.
So, visitors, if you're here with me in the SCCU Daily Planet Theater, I want you to know you can ask questions directly to Dr. Renee. So all you got to do is wave at me if you've got a question at any point throughout the program now. Wave at me. You can even come up on stage. That way you can get on the Zoom call and talk to Dr. Renee. You'll use the microphone, ask her your question, and then be able to chat. If you do come up on stage, I'll let you know we are broadcasting live on YouTube right now as well. So you will be on the live stream on the museum's YouTube channel, just so that you're aware. And then if you are watching on YouTube, I see there are a lot of folks tuned in right now. That's fantastic. You can type your questions into the chat on YouTube. I've got it pulled up, and we'll pose your questions to Dr. Renee as well. And hey, if you're up on the balconies, I see you up there too. If you've got a question, just step up, wave down at me, and then you can yell, and we'll repeat your questions into the microphone. So, Jen, you said that you found a pile of fossils in one of these quarries. how did all of these different bones wind up in like one pile? Like, why isn't it spread out in a nice skeleton where you know where all the bones belong already?
I really wish that all the dinosaurs would play in a nice, even package. That would make our jobs a lot easier. But what probably is happening is we have a whole bunch of critters, not just dinosaurs that died and then got washed in. Because not only is it, not all in our what we call articulated, so the bones nice and laid out like they are in the body, but they are literally packed one on top of the other, and also in a fairly thin layer. So we're talking about a layer only about yay thin, so not even a foot thick, just full of these fossils. And a lot of these fossils are also showing signs where the ends are eroded away or they were broken and those ends were eroded, so they were probably tumbled a little bit. But that being said, we are also finding everything from, what you think of as a nice large fossil down to tiny teeth, which is very cool as well.
So you think it's not the bones of like one particular animal? It's maybe lots of animals in one pile? Or do you think all the bones from one animal got jumbled together?
I think we've got a little bit of column A and a little bit of column B. So some bones that go to one individual, and you can tell that based on, okay, are they all from the same species? Are they about the same size? And then, of course, everybody only has one left arm. So do we have like, two left upper arm bones? Okay, then we have two individuals. But then there are other critters in there. So for instance, the other day I found a crocodile tooth. So definitely other things going in there.
Oh, very cool. So not even dinosaurs that you're finding. You're finding lots of different animals.
Yeah, it's actually very exciting when we're finding the non-dinosaurs because we love the dinosaurs, don't get us wrong, that's kind of our main focus. But it's really nice to remember that dinosaurs were living in ecosystems just like today. So, just like today, of course, there are mammals, there's also going to be insects and reptiles and amphibians and all kinds of fun things. So, when we're finding all the non dinosaurs, it kind of fleshes out the environment that our dinosaurs are living in. So, what animals are they interacting with? What could they be eating, maybe? What do they have competition with? And that's very cool too, because again, we're not just getting dinosaurs, we're getting all the players on our stage of the Late Cretaceous here in Utah.
Very cool. I think that's so much fun. All right, let's take an audience question. I've got one right here in the middle of the balcony. Yell down at me. All right, Dr. Ane, the question is, how do you get permission to go search for fossils in the places where you look? Is it state governments? Is it the federal government, private property? How does that work?
So you just kind of named the three main players. When you're going out looking for fossils, it's whoever is owning the land that you want to go out on. So for us, we dig on BLM land, which is federal land, which means that we get permits. So the first thing we'll do is we'll apply for a permit to actually go out and look in these areas to see if we can find fossils. Then if we find a promising area like this quarry I've been talking about with all the bones, what we'll do is we'll dig little test pits to see, are there lots of fossils in here? Is it worth coming back and making a big old hole in the ground to try to dig them up? And if we decide yes, then we actually go back to the same people that we applied for the permit to be on the land, and we state our case of like, hey, we think we've got an area that we want to quarry. Here's some, test pits we dug. It looks very promising. Will you allow us to quarry here? Because, it's one thing to be walking around the land. It's another thing to be making quarries. It's a lot more onto it. So not only do we apply for these permits, but then we also report each year. So when we're going out, we report to them, where we're going. And then at the end of each year, we also report all the fossils that we pull out. So a lot of people don't realize that a lot of paleontology, including the field, is lots and lots of notes. So we have a logbook and we keep track of every single fossil that we pull out of the ground. So that when we bring them back, we can report to the BLM, hey, this is how many fossils we pulled out. It's also very useful for us to keep track of everything because once they're all nice and cleaned, the hope is they're going to be accessioned, so put into our collection for future researchers to use.
Very interesting. Very cool. All right, let's take another question. All right, so the question is, One of our visitors says that they feel like they hear a lot about fossils coming out of Utah. Is Utah a hotspot for this sort of thing, or why would we get so much news about dinosaurs and other ancient life out of Utah?
So Utah is definitely a good state to find fossils, and I think in this case we're talking about dinosaur fossils, all kind of around this western part of the United States. So the Dakotas, Montana, Wyoming, Colorado, down into Utah, New Mexico. It's great for dinosaur fossils for a couple of reasons. First off, way back when the dinosaurs were around, it was a great environment for them to live. Second, it was a great environment for them to die and get buried. So certain environments, for instance, in today's world, like rainforests, recycle nutrients very fast, so things don't really stick around long enough to get buried, hopefully fossilized. So when the dinosaurs are around, it was a good place to live and a good place to die. And now that we're around, those rocks are exposed at the surface. They don't have a bunch of trees over them, as you can see, and they're nice and right up there so that we can find them when we're walking around the surface. So you got to have a good place for dinosaurs to live, good place for them to die, and then now that we paleontologists are looking for them, they need to be exposed up at the surface.
How long has the museum been going to Utah looking for fossils? Do you know?
So I'm one of the newbies, actually. This is only my second year, but we've been going out here for quite some time to this particular area. I think, if I remember, Dr. Zano said about 2008, which is quite a while, and we're still finding new things all the time. So I think that's another misconception, is a lot of people are always surprised that we're finding new things. But let me tell all the future paleontologists, every year, erosion clears up more rock, we find more fossils, we find sometimes new species, which is very exciting. So even a place that you could be going to for decades, you can be finding new things.
Yeah, I remember just a couple of weeks ago, the head of our paleontology program at the museum, Dr. Zano, showed us some fossils of what she believes is going to be a brand new species of ankylosaur dinosaur that they just went prospecting, and right there on the surface, brand new species of dinosaur never seen or described by science before. So the discoveries are incredible that the team is making out there. Which, you mentioned this Utah landscape, Dr. Renee, and it's beautiful, gorgeous, but I don't see a hotel for miles. How are you staying out there and doing this work?
So part of our permitting allows us to camp here. So we're all living in tents, no showers. Baby wipes are your friend. So we do a grocery shopping run about once a week, put them in big old coolers with ice. We've got a couple of tents that we use for storing equipment, for storing food. In case we have really bad weather, we can all get in there together, but then everybody has their own tents. So you really are off the grid. I am literally standing on a hill. It's one of two hills here that we get some cell service. So you kind of have to cut yourself off from the outside world. But really, it's great. It's really nice to wake up, and I get some of the most spectacular sunrises and sunsets out here. So it's kind of nice to separate yourself and just think about, hey, I'm in one of the most beautiful landscapes in the United States looking for fossils, which is something I've wanted to do since I was little.
So there's some questions online about some of the things that maybe you're finding. Like one of our viewers wants to know if you found any insect fossils and maybe how many dinosaurs you think you found.
Okay, so we have not found any insects. We have found birds as far as some shells like shellfish. Find some of those here. A little bit of some carbonized plant material as well, as far as your not vertebrate, not bone fossils. And then as far as different kinds of critters that we think we found this year, we definitely have some crocodile stuff, like I mentioned, some teeth. We have, not quite sure which critters yet, but we have some theropods, some meat-eating dinosaur teeth as well. We've got the Eolambia. We have that new ankylosaur. We just pulled out a large fossil that we're not 100% sure what it is. So TBD, mystery fossil, which are some of my favorites because we all sit around at camp trying to think what it could possibly be. So I'm excited to see that all cleaned up. Um, again, lots of logos. We have some fish scales. Don't think we have any eggshell this year yet, but we usually find eggshell around here. And in fact, if anybody there at the museum goes through the exhibits, you'll see one of our nests that's from Utah, which was pretty cool. What else did we find this year? That's mostly what we found this year. But we're only 5 weeks in. Yeah, we got plenty of time.
Plenty of time. Plenty of time. Now, there's some more questions coming in online. I'll remind you, if you're here in the theater with me and you've got a question, just wave at me. You can come up and use the microphone to chat directly with Dr. Renee, or you can just tell me your question and I'll repeat it for you. And folks watching online, you can type your questions and thoughts up as well. For example, Elias wants to know, what are some of your favorite dinosaur discoveries, and then specifically your favorite feathered dinosaur discoveries?
Okay, so I think let's go with the feather first. I think the fact that Taphonomy, which is a relative, very far removed, but a relative of basically like Triceratops, so a relative horned dinosaur has feathers. That's weird to me. That's pretty darn cool, since most of the feathered dinosaurs that we think of are the theropods, meat-eating dinosaurs. And in fact, we have lots of feathered theropods. They're called birds. So all those birds that you see flying around, swimming around, walking around today are feathered dinosaurs. And then for my personal things that I have found, again, I'm fairly new to the crew, so I think one of the coolest things I found with this group is big old ankylosaur teeth. I love ankylosaurs. They're very cool. We were jokingly calling it a tank puppy out here. And then in my previous job, I used to dig in rocks that are even older than the rocks we're digging in now. I was digging things about 150 million years old. And we found a articulated, so altogether, Allosaurus, which is a big meat-eating dinosaur, not as big as T-Rex, but still pretty darn cool.
Oh, wow. Yeah, that's very cool. Very cool to find. All right, let's take another audience question right here. Did you come up and use the mic, or you can yell from there? Yeah, come on up. All you got to do, tell us your name, and then Dr. Jen is right there on that screen.
Hi, I'm Priel, and so I was wondering, do you ever work with like biologists or anything to like piece together like evolutionary trees or anything of like fossils you find, or like even figure out like this is like a descendant of this, or like this bone correlates with this? So like what kinds of scientists do you partner with and work with?
So that's a great question. Paleontology is actually very multidisciplinary. We all come from different backgrounds. So yes, absolutely, lots of evolutionary biology that we tie in with, anatomy. A good chunk of my paleontology friends teach comparative anatomy. I work with a lot of veterinary scientists because I do a little bit of paleopathologies, which is injuries and diseases in the fossil record. Believe it or not, though, I'm a chemist, which I never thought I would say on screen because I loathed chemistry as a high school student. But I do a lot of chemistry, so I look at the chemical makeup of the fossils to look to see how they fossilize, but also to see if there's any original chemistry. So some of you, if you came around the Dueling Dinosaurs lab, might have seen something that looked like it was at a Star Trek of us zapping things, as us looking at the chemistry of the fossils. And I get to use big scientific facilities called synchrotrons to do that as well. But yeah, paleontology is very, very multidisciplinary. We have people who do computer modeling. We have people who do biomechanics, isotopes, comparative anatomy, taxonomy, taphonomy, cladistic. All those different fields tie into paleontology. So if you're someone who thinks you want to be a paleontologist, you're like, man, but I don't really like rocks. I mean, I'm sorry, rocks are cool, but you could still definitely be a paleontologist.
What is your background in paleontology? How did you come to this field?
So I kind of have two different routes. Ironically, the hat that you see me wearing is the hat that was given to me on my very first day as a high school intern in a prep lab where I first started to learn how to do fossil preparation. So this hat is older than most of the people in the audience, probably. So my one side of training was volunteering and interning in fossil preparation labs to learn how to prepare fossils. So that's cleaning them, conserving them, fixing them, getting them ready basically for the rest of their afterlife, whether it be in collections, on display. And then the other route was going through different universities. So my undergrad is in geology, and then in my master's and my PhD, I went on to do a lot of geochemistry. So again, looking at differences in how bones are healing, how they're fossilizing, if there's any original material. That's actually sent me all the way to England. My PhD is from the University of Manchester in England, which is also pretty cool because I got to see a whole other side of the world and kind of see how they do things over there. But yeah, and it's also been, I think, tying in a lot of connections with people I met throughout my different university days and also lab days, because we're always learning new things from different people. So it's really great to have this enormous pool of people that I've gotten to work with over the years that come from multiple different backgrounds who can help me when I'm like, hey, I know this could help answer my question. Could you help me with that? And they say yes. And you're like, excellent, do research. This is amazing.
I love that. That's amazing. All right. Any other questions here in the theater? Wave down at me. Just let me know. Got another one? Yeah, sure. Come on up. Or yell. Okay, yell. All right. The question was, what's the best time and place to die if you're an ancient animal and you want to become a fossil?
If you want to become a fossil.
Is that right? Did I get it? Okay.
Okay, so you want to be in a place that you're going to get buried fairly quickly, because if you stay out, Mother Nature's really good about recycling things. So you're going to have scavengers, plants like to have decomposition, all that kind of stuff. So usually, maybe in a place where you're going to get flooding frequently, so you get covered up real quick. Don't go to a rainforest. Bad place. Don't go to a rainforest if you want to be a fossil. Also, probably nowadays, don't go to a place where they're going to be doing a lot of land development, because we can't find you if you're under a building. So you want to be a place like next to a river, or some places going to have frequent flooding, so you get buried fairly quickly.
So that scene in Jurassic Park where the can of fake shaving cream gets covered over in mud and a flood, that's what we're looking for.
Yeah, but maybe not on a volcanic island, because that could also cause problems.
Not by a volcano, and not in the tropics. You just said.
Yeah. Another good place
right,
could actually be out here because things dry. So.
Great question. How big is your team? How many people are out there with you?
Okay, well, right now we're actually a fairly small team. There's only 5 of us, including myself. We've got a couple of students and one of our preparators and me. But believe it or not, we still get quite a lot done. So we're small but mighty.
Excellent. And then, did I see another hand go up? 3rd floor. I'm going to the 3rd floor. What's your question? Just yell down at me. Oh, hi. They're just waving at you, Dr. Jen. Let's go here, balcony. So, Jen, if there were probably dinosaurs that lived in rainforests, does that mean that we're missing an entire group of these animals?
Well, rainforests are actually fairly new, geologic speaking. So kind of the closest things we have for majority of the dinosaurs are mangroves, which are also very productive. And we do have some mangrove deposits that I've run before. But you're absolutely right. There are a whole bunch of dinosaurs that we're missing just because those 3 criteria are very hard to hit. In fact, that's one reason why it's very rare to get dinosaurs on the east coast of North America. They were here. In fact, the first dinosaur fossils found in New Jersey, I should say found and described as dinosaurs. So they were here, but the Appalachian Mountains were actually about as high as the Himalayas, and you had a whole bunch of erosion, which just did not make things great for getting buried. And you also, of course, have lots of trees here. I just said trees, like to eat up nutrients. So unfortunately, here on the East Coast, even though there were dinosaurs, we just don't get as many fossils, and when we do get them, they're usually not as spectacularly preserved as the ones that we see out west. They are still found. So Hadrosaurus, Streptosaurus, all those cool guys are from the East Coast.
Okay, so there's going to be dinosaur species or even maybe groups of dinosaurs that we'll just never know about, perhaps because they lived in environments 100 million years ago that just weren't conducive to fossilizing.
Yes, or not conducive after they were buried to actually being preserved as fossils. And that goes for a good chunk of life. You figure how many millions and millions of species have been on this planet, and how few fossils in them we actually find. Fossilization is actually a pretty spectacular thing, and we're very lucky that we have the fossils that we have.
Fascinating stuff. If you're just joining me here in the Daily Planet Theater, we are chatting live with museum paleontologist Dr. Jennifer Anay, who is in central Utah right now, working dinosaur quarries to bring fossils back to the museum. Although, I guess, well, here's a question. Come on up if you want to say hello. And then I've got another question for you, Jen. Just tell us your name and then your question.
Hello, Dr. Jen. How are you? My name is Gopal. We are visiting from Pennsylvania, from Philly. And I have two daughters. So next generation, the question for you is, what is the message for the young students? They are heavily involved in science. Like my daughter wants to do astronomy, and that's why we are in the college tour. And my little one wants to do medical science. So what are your advice to this new generation, next generation? Thank you.
So first off, shout out to Philadelphia, because that's where I got trained as a preparator. So yay. And for future scientists, I would say have an open mind and don't be afraid to think outside the box and be creative in how you go into your field. We're finding, more and more that think how interconnected sciences can be and how pulling different ideas from different sciences can really help. So I would just say keep your mind open to trying new things and experimenting. And, if you're thinking of those fields, don't think that you have to go a set course. Get creative with it. And that's kind of what I did. I'm doing chemistry now, which I never thought I would say in a million years. But yeah, have fun with it. Have fun in your career. Because when you have fun with it, that's when you get creative and that's when you discover new things.
Excellent advice. Excellent stuff. So, Dr. Nate, what happens next? You found the fossils. You said you finished up a quarry. The fossils are packaged up, and they're going to come back here to Raleigh. Is that what happens next?
Eventually they will. So again, we're still working out here in Utah. After myself, we'll have Lisa Herzog out in Utah for a couple more weeks. And then we do the long drive from Utah all the way up north to Montana, where Eric Lund will be taking over in Montana. We've got some cool fossils there. And after they're done in Montana, then we do the even longer drive all the way back to Raleigh to unpack the fossils.
I guess you can't FedEx the fossils from the desert back to Raleigh, make it easier?
I mean, usually FedEx is by weight, so I would not recommend it. It's also really nice, these are things that we've spent so much of our literal blood, sweat, and tears into digging up. You don't want to give it off to somebody else. It's nice to know that they'll be safe with us, and also to keep them all together. If you remember I was saying we keep that logbook of all the different fossils, so keep them together so that nobody gets lost. And then when the crew gets back to Raleigh, we'll have a big old unpack party. We'll unload all the fossils. We'll unload all of our equipment. We'll go through all that stuff, start sorting them based on where they're found, what priorities we have for what should be prepped first. So it's also a little bit of fun after field season team building of going through all that.
Very cool. Well, I will look forward to seeing the paleontology party in the museum when the team gets back. But of course, before then, we'll look forward to hearing more updates from our paleontology team as they traverse the American West looking for the latest and greatest ancient life out there. Dr. Jen, wait, did you have a question? You were just waving. Okay. Well, everybody can wave bye to Dr. Jen. Jen, thank you for being with us today.
Thank you, guys.
Awesome stuff. Thanks for taking the time out of your busy field schedule to chat with us. And hey, thanks to all of you for visiting the Museum of Natural Science today. Thanks for tuning in online if you joined us on YouTube. We'll be back here doing this again next Friday at 12 o'clock noon again. So you can tune in online. Head to naturalsciences.org to get the link. This program is called Dino Dig Live when you go looking for it on the events calendar. That way, even if you're not in downtown Raleigh, you can tune in and get the latest updates from more members of our paleontology team who are going to be working on our fossil sites. Thanks again, Dr. Anae, for tuning in, for joining us. Everybody, have a great Saturday. We'll see you again soon. Bye, everybody.